Hello and welcome to this session at J4K. Thank you for joining me. My name is Grace Jansen and I'm a developer advocate at IBM in the UK, if you couldn't tell from my accent. And I'm going to be talking about sort of cloud native. And today we're going to be taking a look at sort of what does cloud native mean anyway? If you guys have any questions throughout this session, then feel free to put them in the Q&A section in Hoover, and I'll try my best to get around to as many as possible at the end of this session. If I don't get around to any, I have included my Twitter handle here. If you'd like to give me a follow or send me a message or a tweet, feel free to. It's at GraceJansen27, and I can get back to you that way as well. So I cover a range of topics as a developer advocate at IBM, including sort of reactive technologies, Java, the JVM, and also cloud native technologies. So that's why I was really interested in getting into the nitty gritty of what does it really mean to become cloud native? So I started thinking of this question of, okay, what is cloud native? How do we define it? What does it really mean when we get down to that nitty gritty? So I thought the best way to think about it and the best way to sort of find out what the industry thinks cloud native is to take a look at sort of vendors and companies that offer cloud native solutions and cloud native products. So I had a look at some various company websites and sort of documentation that they have on what cloud native really is, and started comparing them to try and get this overall opinion of cloud native. And I found something interesting. Now, I tried not to focus on sort of something that's just about technology, because clearly it's being cloud native isn't specific to a technology or a language, for example, because you can build a very good cloud native application in Java or JavaScript. This isn't part of the cloud native definition, just like, for example, just going down the Spring Boot route isn't either. So it's not about a specific technology, it's about something else. What is that something else? So the first website I took a look at was VMware. And actually, a lot of these vendors that I'm going to be showing you the definitions that they've included are actually sponsors at this conference. So all very relevant to Java, all very relevant to cloud native, and they have a lot of experience in this area. So the first one I took a look at is VMware. If you're not familiar with this organization, they created things like VMware virtualization, Tanzu Kubernetes platform, and things like Cloud Foundry and Spring Boot. So they've got a really long history of being in this cloud native environment. So what do they say? So you can see I've included the links here for each one, documentation, so you can go and take a closer look if you want to after this session. But what they say is they say that cloud native is an approach to building and running applications that exploit the advantages of the cloud computing delivery model. They then go on to say, and it's sort of reflected in this diagram here on the right, that cloud native development incorporates the concepts of things like DevOps, continuous delivery, microservices, and containers. Now, the one that I found interesting in all of that was microservices. Microservices is often sort of coupled with this cloud native definition, and it's something that I saw appearing again and again. But I started to question, is microservices actually explicitly linked or needed to be able to count yourself as cloud native? And I saw this pattern repeating. So I also went to Microsoft. Again, Microsoft's documentation is there if you'd like to take a look at it. I pulled out a few key aspects from that document. It's quite large. So I just picked out a few key points. They refer to cloud native as being sort of about speed and agility. But to me, these things are more values that you want to achieve through using the cloud, but it didn't really tell me much about what cloud native really is. Actually, their diagram later on and sort of the following paragraphs help with that. Here in their graphic, you can see that they actually say that cloud native applications utilize things like modern design, containers, backing services, so things that you might find available in clouds. You've got automation, which sort of links into that DevOps and that continuous delivery aspect of it. That modern design is sort of looking at things like 12-factor applications, but interestingly enough, they also include microservices within that. So they identify it as a key part of being cloud native. I took a look at another one, which was Red Hat. So this was interesting because they start with this, there's quite a strong statement of sort of what cloud native is. So they say cloud native applications are a collection of small, independent, and loosely coupled services. Now, although they don't explicitly in that section say microservices, small, independent, and loosely coupled services sort of is the byline of microservices. And actually later on that in that page, you'll see this diagram here, and it says about the various aspects of cloud native, and that includes DevOps, containers, and again, microservices. Now they pull in APIs as the fourth one, perhaps because they've used sort of continuous delivery as part of DevOps. So all of these companies seem to have this similar vein about, it's how you, cloud native is about how you develop and how you deploy microservices. They all state microservices within this sort of definition. Now, the interesting thing about Red Hat is that actually right at the very end of this sort of definition document, there's this sentence that I've included. It's the second quote here. They actually say, you don't always have to start with microservices to speed up application delivery as part of cloud native apps. So this is kind of important because although they do state at the beginning and they include microservices as a concept that's needed for cloud native, they do make the statement that actually, you don't have to use it 100% of the time, or perhaps the first time you're trying to move your application to be cloud native. So that was an interesting sort of point I saw there. And actually moving on from this, sort of bouncing off this idea that actually some companies are recognizing that microservices aren't necessarily needed for cloud native, I looked at the CNCF. Now, the clue is in their name. They are literally the Cloud Native Computing Foundation. So surely they know what cloud native is. So their definition I found interesting. They say that cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments, including public, private, and hybrid clouds. Now, although they mention sort of technologies or components like containers, service meshes, and microservices here again, they just say that they exemplify this approach. They don't say they're necessarily needed or explicitly linked to cloud native. So in this definition, I found it interesting that they sort of, again, acknowledged that there are other approaches that potentially fit within this cloud native approach. And actually, I saw this sort of, I guess, mirrored in sort of industry adoption of the various different application styles. So taking a look at the different application styles, there is a spectrum. There is a spectrum of styles that goes from sort of the very true monolith all the way through to functions as a service. So you've got sort of these in-between stages. And I say it's a spectrum because it's very rare that an application falls solely into one category and isn't on this sort of gradual scale, as I would say. So that's why I'm using this term spectrum. So you've got things like macroservices and microservices as well in the middle there, somewhere along the line. So arguably, if you take a look at the very right-hand side, we're looking at sort of functions as an approach to software delivery. And you could arguably say this is sort of the most cloud native thing you could probably come up with. And we say this because when you're deploying functions on premise, you're sort of not really getting the point of functions, because normally when you're using functions as a service, you're paying per call to that particular function. Whereas if you're already paying for the underlying infrastructure, that model doesn't really make much sense. Microservices is where we're getting slightly more coarser grained. And that's sort of where we tend to have the industry definition of cloud native. And then we have things like macroservices, which are sort of, if you have, say, multiple microservices that are quite tightly coupled, you might want to combine them into sort of a slightly larger service, which are now being coined sort of macroservices and then on to monoliths. And actually, what's interesting is that, we're seeing this sort of trend away from microservices within the industry as the, a solution to all, as this almighty solution that everyone can utilize and is best for everyone. Actually, if you look at the Gartner reports and their hype cycle, microservices and functions are actually in the trough of disillusionment. And this is backed up by stories of organizations who have perhaps tried to do microservices, but provide us with examples of failures. And a lot of that is about, is that actually the right approach for everyone? Or, can other application architecture styles be better suited to particular applications and particular organizations? So you don't just have to believe me about this. Maybe you're skeptical about this movement away from microservices. Don't just take my word for it. Here are various different analogies, examples, comments made by sort of industries and organizations, and and influencers within the industry that show similar moves away from microservices and sort of a greater appreciation from the other styles of architecture that are out there. So you can see here that we've got examples from people, from companies such as Uber, showing that they're moving away from microservices to macroservices. And so there is this sort of industry move to appreciate that diversity. And, you know, this is the same that we're seeing in surveys, polls that, you know, general people within the industry are contributing to. If you have a look at the Jakarta EE developer survey between 2020 and 2019, you'll actually see that monoliths went from 12% in 2019 up to 25%. So there was actually an increase in the interest in monoliths, which was interesting. And there's also, you can see there's a poll here on the right-hand side that my colleague did, Jamie. And you can see here that actually monoliths and microservices have a fairly even interest rate from the people that were surveyed in this poll. And actually macroservices, even though it's quite a new term and a new architectural style, is still sort of quite high in terms of amount of interest in this type of architecture. And this is actually because a lot of companies, organizations, people who've been trying to follow suit from the big Netflixes and all the big corporations who have gone to microservices and shown that as a successful architectural style for themselves, who have been trying to copy that in their own organizations but aren't necessarily suited to it, are often falling into this trap of the distributed monoliths. The fact that they're taking all of the downsides of microservices, being distributed, having to try and, you know, monitor all of those distributed services. So you're taking all the negatives of the microservices, but you've also got all the negatives of the monolith because you're quite tightly coupled and you've not completely decoupled or isolated the components of your application. So this is the trap we're trying to avoid. This is, you know, just because microservices worked for one organization doesn't mean they're necessarily going to work for your own. And that's why it can be important to really think about your architectural style before jumping into this automatic, oh, to be cloud native, I must go down the microservices route. That's not necessarily the case, as we've just seen. So in order to look at what kind of architecture is best suited for your own application, I've sort of created this useful slider. So here I put up some of the important factors that influence sort of the architectural choice that you might make for your own application. And you can see here that not all of these are strictly related to code. A lot of them are also related to your organizational processes, how your organization is laid out, the resources you have available. So it's important to not just think about your application code and logic, but also to think about how prepared you are for each of these architecture types in terms of your actual organization and the way you're set up in terms of resources. So you can see here, these are just some example factors that I would say are generally important to most organizations. But if you think of others, you can always add them to this list and utilize this slider system to figure out where your own organization or your own application should fall, and to work out, you know, should you be more towards the monolithic or the macroservice side of things, or are you looking more at microservices and functions? And this just helps you to sort of take a second, pause, and really think what's best for my own application. It doesn't necessarily have to be microservices for cloud native. So where does this actually leave cloud native? Going back to the original question, okay, we figured out it's not necessarily explicitly linked to microservices. So what is it and why do we care? So we care because, you know, we want to become cloud native because there are many reasons that we can benefit from being cloud native. One is cost. So the fact that, you know, we're utilizing this underlying cloud infrastructure means that we're using this sort of economies at scale. So because these cloud vendors are able to do it for lots and lots and lots of organizations and people, they're able to cost save and pass those cost savings on to you. So we can enable greater cost savings there and also greater cost in terms of utilizing only the resources we need. We're able to expand and shrink those resources when needed, depending on the load to our system. There's also speed. Speed is another important factor for investing in cloud and caring about becoming cloud native. And that's because, you know, in terms of cycles, in terms of getting up resources and provisioning resources in your own data center, that can take a lot longer than just requesting already provisioned allocations in a cloud vendor. Obviously, depending on permissions and finance, you can provision as and when you need it. So that's speed to getting those resources when you need them. and also fashion. You might not think of technology or software development as a fashion industry, but we kind of are. We follow trends, we follow fashions, and it's what gets our users excited about using our software, because we're able to offer them these fantastic new features, increased speed, increased usability, and say increased reliability. So we are actually a fashion industry, and investing in cloud enables us to follow those fashions and trends and to really enable innovation in our own applications. So now that we know that we want to go cloud native, how do we do that if it doesn't mean microservices necessarily? So I was looking at, okay, when you take away all of the other stuff, is the essence of cloud native? And I found in my search for definitions, I found a really great definition that I really resonated with when it came to sort of this essence. And that was this definition by Paul Fremantle. Again, I've included the link there for you to take a look at. And it was just, cloud native should mean it works well in a cloud environment. Simple. That is what cloud native is all about. It's regardless of your technology, your language, your stack, the architecture style. It is just about designing applications that work well in the cloud. Yeah. And so actually, when I was looking at sort of the essence about the characteristics, the behaviors that enable applications to work well in a cloud environment, I took some of those keywords from the sort of definitions that we had earlier in the slides, and I got rid of all of the words that I thought were specific to a type of architecture, to a type of technology, to a stack. And what I was left with were just the generic behaviors, the generic characteristics that really lead to enabling your application to really thrive in the cloud and not just survive. So actually, it was all about enabling observability, enabling scalability, being able to be resilient and rapid, enabling loosely coupled services, regardless of how big or small those are, macro, micro, whatever. It was also about enabling sort of, I guess, this hybrid approach, enabling you to be able to switch sort of cloud providers or underlying infrastructure or all of the rest of it. So these were the aspects that I found came up time and time again in all of these definitions and these generic characteristics and behaviors. So how do we actually go about taking these characteristics and behaviors and actually making them actionable, enabling them in our own applications? So this is about realizing that cloud native essence. And actually, I think one of the best methodologies you can follow is arguably the 12-factor methodology. And I love this methodology because even though it's about 9 or 10 years old now, and there have been iterations, so if you want to go and check out the 15-factor methodology, that is sort of an iteration upon this. But even though it's slightly old, this concept, these 12 factors still apply today. And that's because they're technology agnostic, they're language agnostic, they're platform agnostic. They apply to every application. And it's really taking those key things we need to do in order to work well in the cloud. And actually, if you map those out, and we're going to map on those characteristics, you can see how these 12 factors can enable those characteristics. So let's take a look at a generic application now. So here I provided a generic application. It can be in a public or a private cloud, and I'm just mapping onto that the 12 factors that you saw in that previous slide. If you want to take a closer look at these 12 factors, I've included a link there. It's quite an easy link to find. If you just Google 12 factors, it should be one of the first ones that comes up. And you can read all about it in more detail there. There are tons of blogs and articles on this. So back to our application, mapping out our 12 factors. Let's take a look at what that looks like in terms of where they fall in our application development. So you can see here where they start to fall. The arrow that we've got here is sort of our development pipeline. And then you can see where the application is actually running inside that private or public cloud. So we've got things like our code base right at the very start, utilizing that build, release, run factor when we're actually creating our application, and that dev prod parity factor. So enabling our development, our testing, and our production environment to be as close as possible so that we don't get any sort of unforeseen errors or failure points. Then we've got things like inside our application itself, we're looking at things like external configuration, port binding, enabling dependencies, utilizing backing services within that cloud infrastructure, being able to monitor and observe logs to check how our application is doing in terms of enabling us to see that in real time. admin processes. And then within our application itself, looking at processes, concurrency, and disposability. So you can see how each of these 12 factors sort of comes into play in that development process for our application. Let's map on those key characteristics and behaviors that we took from the very essence of being cloud native. Here you can start to see how these 12 factors actually enable those characteristics and behaviors. So having our build pipeline enabling us with a code base, build, release, run, and dev prod parity enables us to rapidly produce excellent code to put into our application. And that's important because we need that rapid iteration, especially in our agile way of working now. Enabling observability through logs, enabling scalability, for example, within our application itself, making sure that our services, the components of our application are loosely coupled by having that external configuration, for example, and ensuring that our dependencies, we don't have dependencies sort of tying the components of our application together and coupling them again. And enabling sort of resiliency and robustness in case our application were to go down or any component within our application goes down, enabling that inbuilt behavior to bring it back up and to continue as normal. So you can see that here is where we can enable those generic characteristics through following this sort of map that's provided by the 12-factor app methodology. But how do you actually go about sort of considering the 12-factor app methodology is quite generic, it's not technology specific? I've linked it to a few sort of open source technologies and tools that you can utilize when you're trying to go cloud native so that we can enable these characteristics and these 12 factors. So let's take a look at, again, this is just a generic application, and I've applied those technologies that you might want to utilize if you're trying to achieve those 12 factors and thus the essence of cloud native through those characteristics. So you can see here, for example, you might be using Git for your code repository. That was that first 12 factor that we saw. You might be triggering builds within that build pipeline, using things like Tekton, Travis, or Jenkins. There's also testing to think about as well. It's really important that you consider that dev prod parity. And that's not just about the development and the production environment. You also got to think about testing environment. Is your testing environment as close to production as possible so that you can really test your application before it goes live and check for potential failure points and errors? And to do that, we can introduce testing techniques like microservice testing or JUnit, for example. So these will enable us to achieve that dev prod parity and really get as close to production as possible. And then we've got things like if you're using repositories, for example, you're probably going to be using a mirror of Maven Central repository for things like artifacts. You're probably going to be publishing to a Docker registry somewhere, or perhaps pulling things from Docker Hub. So you can see those technologies reflected here within that circular part of the diagram. And then when we actually get into the cloud environment, commonly you might be using Kubernetes, although there are obviously other service types, and there may be things that you do in terms of the way you design and deploy your application to suit the different application runtime types. Here in this example, we're just using Kubernetes, and we've also got containers and the application within there. And then for things like telemetry or monitoring, linking back to that observability that we were talking about as a characteristic, you might be using things like Elasticsearch, FluentD, and Kibana. So you can have this stack that enables you to create dashboards and have alerts and so on to really help you understand better what's going on within your application and within sort of the broader system at large. So you can see how these technologies and these tools, which are all open source, and you can have a go with them yourself, you can see how they can enable those 12 factors and how those 12 factors can enable the characteristics that are the essence of cloud native. It's what cloud native is really all about. So let's take a look at how this varies depending on the architecture style. Let's bring it right back to those original definitions where we were seeing cloud native being linked time and time again to microservices. So let's take a look at monoliths sort of as our first example. So here's a cloud native monolith. You can see it's almost identical. In fact, the only thing I've changed is the name of the slide. So you can see that actually monoliths, microservices, it doesn't matter what underlying sort of architectural style you're using. I've kept them the same here because actually it just depends on how you built your application. As long as you're designing that application to utilize those 12 factors and to be cloud native, then it doesn't matter whether you're using a monolith, a microservice, macroservices. It's just about enabling those key characteristics. It's not about the particular technology, platform, or architectural style that you're using. It's about enabling that essence, those key characteristics, and you can do that by using methodologies like the 12-factor app methodology. And actually, even when you've got, say, multiple microservices, as you can see here, we're not just looking at one, we're looking at multiple. The same applies. You're just reiterating that same pattern in terms of utilizing those key technologies to enable those 12 factors to enable that essence. So actually, I would argue it's not about microservices. Microservices does not equal cloud native. Microservices are a fantastic way to enable cloud native if, and it's a big if, your application and your organization are set up with sort of to enable microservices so that you can enable that rapid deployment, that the teamwork in terms of collaborating to create those loosely coupled services and those boundaries, whether you're able to sort of provision the resources to enable microservices. So regardless of the underlying application architecture you choose, you can achieve cloud native and you can achieve that essence. So in summary, hopefully this presentation has made you pause and perhaps think about what you had in your head as what cloud native really means. And hopefully it's helped to show that it's not necessarily explicitly linked to microservices. Cloud native is essentially about making applications that work well in the cloud. It's about exploiting cloud delivery models for faster time to value and cost optimizations. And it's about engineering your applications for cloud technologies and cloud delivery. Okay, I bashed a bit during this presentation on microservices, and I do apologize for that, but it was just to get the point across. But microservices are still an important tool. They just aren't universally applicable or, importantly, required for cloud native. So don't just, take this presentation and go, oh, well, I can't use microservices. Consider them, but do just consider them. Don't automatically jump to them. Think about what's best suited for your own application and know that regardless of what application architecture you choose, you can still be cloud native. And it's about, hopefully from this presentation, what you take away is that understanding that you do need to consider multiple different factors, your application needs, your business needs, your organizational capabilities, and choose the right technologies and architecture to suit you. Please feel free to use the slider in the slides and to add your own factors to try and figure out where your application best suits. I've got some useful resources if you'd like to go away and do some further reading, as well as the links I provided throughout this presentation. So there's a couple of links here that are articles that we've written about, how do you choose the Java runtime that's right for you? Why is modernizing important in terms of your Java applications? And then right in this last one here, if you're interested in becoming I guess, getting hands-on and getting interactive with some of the technologies and tools that I've mentioned throughout this presentation, including Kubernetes, including things like some of the monitoring tools I mentioned, like Kibana, Elastic, and Elasticsearch, and then things like the microshare testing that I mentioned as well in that sort of cloud native instantiation, then we have some interactive labs that you can take to be able to get hands-on with that. And they are free and it's all using an online environment. So if you want to have a go at that in your own time, you can use this link here. Each lab is about 20 minutes and is focused on a specific technology, all using open source technologies. So all freely available for you to take a look at. And you don't need any prerequisites on your local machine, which is fantastic. So I definitely recommend having a go with that if you're interested in some of these cloud native technologies. So with that, I think we're almost at time. So thank you so much for listening. Hopefully I've made you think. And as I said, if I don't get around to any of your questions, or if you just fancy following me on Twitter, feel free. At Grace Jansen 27 is my Twitter handle. So I'm going to move on to the Q&A now. So I've got some Q&As coming through and I will do my best to answer them all. If you think of any, feel free to add them to the Q&A section in the application. So first question I've got through is, I like the statement that microservices and functions are not the solution for everything and have their drawbacks. I totally agree. You cited many others. What's your personal opinion of microservices versus macroservice versus monolith? So what's my personal opinion? I think microservices can be a fantastic solution to becoming cloud native. They really help in terms of conceptually people to really think about, okay, how am I sort of creating bounded contexts that have to be really loosely coupled and isolated. And it's a really great sort of thinking tool to help people get into this mindset of, okay, I'm breaking my application up into sections, and those sections have to be, completely completely isolated, completely loosely coupled. They need to have great APIs, very well bounded, able to be able to communicate effectively with the other components, and also able to be replaced easily as well. But I think they're a really great learning tool, a really great conceptual tool. But I think that realistically, it's not necessarily, I think people jump to it too quickly, if I'm honest. I think people see large organizations like, for example, Netflix with these fantastic success stories, and I'm so glad it's worked for them. But people assume that they can then mirror that success when they don't necessarily have the same huge amounts of resources or money or time or energy to be able to make it a success when it doesn't necessarily suit their application style or organizational business needs. So I think that every type of architecture I've mentioned in this presentation is a valid architectural style, and there's a spectrum. It's a sliding spectrum. I don't think a single application falls within one. So microservices, in my opinion, personally, this is just personal, I think they're a great learning tool and can be fantastic for some organizations, but they're jumped to too quickly, and people should spend more time really thinking about what's best for their own application, personally. And I've seen many great examples of sort of organizations utilizing other architectural forms. I think works really well. As you saw, some of the industry comments that were made by companies like Uber, they're moving away from microservices. So there are examples online if you want to take a look yourself at other organizations and how they're utilizing these alternative application architecture styles. Could you elaborate on how OpenLiberty supports microservices and monoliths? So my link will help you with that. So the link that I provided here in the Interactive Lab tutorial catalog, and actually in all of these links, is utilizing OpenLiberty technology. So if you head into the interactive labs, all of those labs are utilizing OpenLiberty under the covers. OpenLiberty, for those who aren't familiar with it, is our open source web application server. So we used to have something called, well, we still have it, but originally the original product was WebSphere Liberty, which you might have come across as sort of traditional WebSphere. And then a more lightweight cut down version was made of that called Liberty. That was still proprietary. And then that most of that got open sourced to become OpenLiberty a few years ago. So OpenLiberty is really sort of most of the key components of our proprietary products that you have there. So it's a fantastic opportunity for you to sort of get hands-on with that technology. OpenLiberty does support microservices framework. So if you're interested in utilizing any of the technologies I showed in these diagrams, it supports all of those. And you can take a look at our documentation by heading to openliberty.io/documentation. So you can head to that openliberty.io site, and we have an entire documentation page section of that, which goes through each of the sort of aspects that we support. We also have a blog there that goes through sort of the new features that we support, the new components we support, and all of those interactive guides in that tutorial are actually based on the OpenLiberty guides that are in that website if you wanted to do it locally on your own machine. So actually OpenLiberty, if you take a look at the Modernizing Your Valuable Java Applications article here, you'll see how OpenLiberty can actually support a range of different architectural styles, including microservices, but also including things like macroservices and monoliths. And that's because we're able to offer a lot of different features that you can utilize and sort of support for other tools and technologies that you might want to use. So definitely check out these articles if you're interested in that. I think I've already covered those questions. So what may be some of the drawbacks of microservices? I think some of the drawbacks are that you do have it becomes more complicated, right? You're trying to deploy more smaller services, and you're deploying lots of them. They all have to be tightly bound. They all have to be isolated. You need to be able to isolate failures, monitor them all, observability for them all. So these are some of the key sort of disadvantages, I would say, and where you can fall into that trap of the distributed monolith. Now, I only have about 35 seconds left for this. So if you want to ask me that question in more detail, I can go through it in more detail via Twitter, or if you tweet me, I can perhaps do an email conversation with you as well. Thank you so much for your questions and for joining me for this session. Really appreciate your time.